Today I'll be deriving or proving the integral of cosine of x without using an integral, so without doing it the easy way. So I'm going to use quote unquote the hard way. So the cosine function would be like this, right? Or yeah, it's not perfect, but you get the idea. So like in my previous integral videos, we're going to split this up into multiple rectangles. And we get this, that the integral of cos x dx from, let's say, 0 to x. I'm just going to do 0 to x for simplicity. And let's say x stops at here. So we want to find the area. And we stop at here. All right? Equals some h. The base would be h. And the height would be cos h. Because when we plug in h here, we get cos h as the height, or y equal cos h, and then so forth, plus dot dot dot, and we do this all the way until we get to x. Okay, and now I need to bring in, I need you to remember some of the trig identities, and let me remember which ones. I think it was, yeah, let's take this. Sine alpha plus beta equals sine alpha cos beta plus cos alpha sine beta, and sine alpha minus beta equals sine alpha cos beta minus cos alpha sine beta. And I want to subtract this trigonometric identity from that, or no, subtract this from this. So we get this, sine alpha plus beta minus sine alpha minus beta equals, well, this and this cancel out because sine cos minus sine cos is 0, and then this becomes 2. So 2, because we change this negative to a positive, and it becomes 2, twice this cos alpha sine beta. All right? Okay. Now, I want to look back at this. I want to multiply everything by sine h, and you'll see why later. So we have 0x cos x. We multiply by sine h. And by the way, lim as h approaches to 0. But I'm not going to write it for the later steps because that would be a little tedious, all right? And let's just factor out the h here. So we factor out h because each of these terms will have h. But I want to keep the sine h inside. So sine h cos h plus sine h cos 2h dot 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 sine h cos x. All right, so I'm running out of space here. So I'm going to ignore this left side here and just write an equal sign. Now, we can turn this from here to here. So let me expand this again. So basically, let me just remove that. Cos alpha sine beta equals sine alpha plus beta minus sine alpha minus beta over 2. Just divided by 2 on both sides. And then let's go back to here. This would equal h factored out. And all right, let's consider, let me think. Let's consider, hold on. Yeah, let me think through this. All right. Okay, let's consider this term. So alpha would equal h, beta would equal h. So this would be sine 2h minus sine 0 over 2. So we first have sine 2h minus sine 0 over 2. Okay, and then let's break apart this formula. This would be alpha would equal, oh sorry, but yeah, beta would equal h. Okay, so beta would equal h, alpha would equal 2h. So we get this plus sine 3h minus sine, well, 2h minus h, that's sine h, because 2h is alpha in this scenario, over 2. And let's go, there's a term, sine h cos 3h, and I'm just going to do one more, all right? Do one more term. We split it up. Alpha is 3h, beta is h, so sine 4h minus sine 2h plus, and you should notice the pattern here. All right, over 2, and if you know the pattern, it's just plus 1, and the difference between the h's must be 2. So the next term will be sine 5h minus sine 3h over 2, dot, dot, dot. Okay, now you'll see that this series telescopes. So what we mean by telescopes is that this sine 2h right here gets canceled out with this sine 2h because they have the same denominator. Sine 3h here gets canceled out with sine 3h. But look, I want you to notice that sine 0 and sine h do not get canceled out. And likewise, you can see why by symmetry of telescoping series, that sine x and sine x, okay, I'll just write it down first. So sine x plus sine x minus h minus sine 0 minus sine h are the only terms that remain after we cancel everything out. Because we'll just look at sine h cos x. So sine h, okay. So the last two terms are sine h cos x and sine h cos x minus h, right? So we use what we used here. So it would be like, oh, sorry. It should be sine x plus h. And this should just be sine x. Wait, no. Yeah, just sine x. All right. So this should be sine x plus h plus sine x. And here's why. These are the last two terms, right? And we want to split it apart like this. So we get that sine x plus h minus sine x minus h over 2. And then this term plus sine, well, x minus h minus sine, hold up, let me think here. So alpha plus beta, okay, x minus 2h, oh rip, I think I did something wrong here. So this is alpha, then we add it, oh, this should just be sine x, sorry about that. Because x minus h plus h is just x. And then x minus h is 2h from this formula right here. So from this formula we get these are the last two terms. And as you can see here, this term will actually get canceled out. And this term will also get canceled out by some terms as we keep on going to the right. Just trust me on this one. It's by argument of symmetry. But if I were to keep on going, like sine h cos x minus 2h, then and sine x cos x minus 3h, you'll see that this gets canceled out and this gets canceled out. And these are only two terms that remain. So we look at this. So we get that sine h 0x cos x dx equals some h times 2 sine x plus h plus sine x minus sine h minus sine 0. Lim as a, oh, now we want to take into account the limit. So we divide sine h, because remember, we're trying to find the integral of cos x, not the integral of cos x times sine h. Cos x dx equal h over sine h. And by your limit identity, you know that as h approaches 0, h over sine h approaches 1. So we have this. All right? And look, as h approaches 0, this just becomes sine x. This is sine x. This becomes 0, and this becomes 0. So in the end, we get 0 to x cos x dx equals, this becomes 1, and we get this. sine x plus sine x minus 0 minus 0 and equal 2 sine x over 2 equal sine x. Hence, the integral of cos x equals sine x. So the biggest part of my argument here would be using this from the trig identities and then using a telescoping series where the first two terms are not canceled out and the last two terms are not canceled out. And thank you for watching this video.